In this lesson, we are going to continue to talk about tangent, secants, and chords and add a few more rules. So last lesson, we talked about tangent segments. This time, we are going to talk about secant segments. A secant segment is a segment of a secant line with at least one of its endpoints on the circle. Okay, so it just has to have one of its endpoints. So for example, AB is a secant segment and BC is a secant segment. But AC is also a secant segment because it just has to have at least one of its points. It's okay if it has two. Okay. The internal secant segment is just called a chord, and then the outside one we would call the external secant segment. Theorem 913 says that if two secant segments intersect in the exterior of a circle, the product of one secant segment and its external secant segment is equal to the product of the other secant segment and its external secant segment. So what that means is that here we have these two lines that intersect at point C out here. So what that means is that AC, this whole secant segment, times BC, the external one, is going to equal EC, this whole secant segment, and this external one, DC. So again, what we just said, the AC times BC is going to equal EC times DC. So the whole segment times the outside one equals the whole segment times the outside. So here, we want to find the length of DC, so we'll label that X. If AC equals 12, so this whole line equals 12, BC equals 6, and EC, this whole line right here, equals 18. So again, we know that this whole segment, AC times BC, so we can say 12 times 6 is going to equal 18 times X. So we're going to take 12 times 6, which is 72, and that's going to equal 18X, and then we're going to divide that by 18, and we're going to get X equals 4. So I know that segment DC is going to equal 4. This says find the length of EC, so we want this whole segment. We'll label that X. If AC, so this whole line right here, equals 8, BC equals X minus 1, DC equals 2, and EC, and this actually equals 3X, so we'll call that 3X. So now what I know, remember, AC times BC equals EC times DC. So here I can take 8 times X minus 1 is going to equal 3X times 2. So we'll distribute the 8, and we have 8X minus 8. 3X times 2 is 6X. So now you can subtract 8X from both sides. That's going to give us negative 8 equals a negative 2X. Divide by negative 2 on both sides, and that's going to give us X equals 4. Okay. Now here it wants us to find EC, so that means we actually have to take this 4 and plug it back in. So we would plug in 4. 3 times 4 equals 12. So we know EC equals 12. Theorem 914 says that if you have a this secant segment, so this external one, okay, BC, if you take BC times BC, and then you take EC times DC, then these are going to equal each other. So we have this tangent segment, okay, the whole tangent segment. So BC, so that's essentially BC squared, right, is going to equal EC times DC. So here it tells us to find the length of AB, okay, so we'll label that X. If DB equals 27, and CB equals 3, okay, inches. So now what we know, right, what we talked about earlier, X times X, right, AB times itself. So X times X is going to equal 27 times 3. X times X is X squared, and 27 times 3 is 81. So here we have a squared, so we're going to take the square root. The square root of 81, right? What times itself equals 81? Well, that's 9. So I know the length of segment AB is going to equal 9. This says find the length of CB. So here's my x. If AB equals 10 and DB equals 20. So again, we know that you take the tangent segment times itself. So 10 times 10 is going to equal 20 times x. 10 times 10 is 100. 20 times x is 20x. Divide by 20 and get x equals 5. So I know that segment CB is going to equal 5. That's the end of tangent, segment, secants, and chords part 2.